Well, it's that time again. It's another Bevy update. This time, we're updating to Bevy 0.8. I have been through this devlog and this update log, and it is very, very long. Bevy added a lot of stuff that I feel like I'm going to skip over because it's very much like improved shaders and then improved shaders again and improved shaders in a different way. So hopefully a lot of that will be skipped and this video won't be 100 hours long. Anyway, new material system. Very much what I just mentioned, improving shaders. They've basically made it so that there's a nice API for adding shaders using the as bind group derive here. And this just basically lets you use Bevy's macro system, or Rust's macro system, to implement new materials without needing to write huge amounts of shader code. And then they've just got some examples if people want to go through that. Again, this is very long, so I'm going to basically be blazing through a lot of this stuff. Talking about things that I find personally important, but skipping over a lot of the stuff that I don't understand. Camera-driven rendering is a huge add to Bevy because it basically allows you to have multiple cameras in a scene without having to modify or edit the render graph in any way, and allows for things like portal effects that they show down here and other like render-based things where you have one camera render something and then another camera render what that camera sees. So, TVs, security cameras, mirrors, all this stuff is now possible in Bevy without any custom modification or changes. You just simply specify a texture that one camera renders to, and then make sure that the camera that finishes is the camera that is your main camera is rendered after they've all rendered to their textures, and you can have amazing effects like this. Then it also allows for things like split screen, as you can now specify a viewport for cameras. And this basically means that whatever they're rendering to, you're specifying that they only render on a section of that. This allows for split screen by having two cameras, one rendering to the left half of the screen and one to the right half, as seen here. And again, they've just got examples of specifying that the second camera has no clear color and then is rendered the primary camera is rendered after the first camera. So render this camera with a default of 0 priority, and then don't clear and render this camera second is how you do that. And then they show this example of one camera and a second camera rendering on top on a slightly different rotation. And as seen, with no clear color means that it doesn't, it's clear, whereas this one is gray. Ergonomic target sizing is basically that each camera holds the size of its render target, as opposed to before when you had to then calculate that when you went to use it. And really the only impact this seems to have is, outside of ease of code access, is that they managed to shrink the convert to world space function to only need the camera's position and the world's position, as opposed to needing things like what window it's in, the image, and that, because you used to have to then acquire the screen's resolution in order to do these math calculations. New camera bundles, because Bevy, some reason, decides to keep flip-flopping on names, is they've gone back to the old naming system of camera 3D bundle and camera 2D bundle, instead of the orthographic and perspective that they did for versions 6 and 7. I think it was 5 that they changed to that. I'm not 100% sure. But this really has very little impact other than needing to find and replace and do a few tweaks. You change the perspective by adding the perspective component. And so that should allow for, I guess, easier changing of 3D cameras, because I'm assuming the perspective component contains the information for the two different perspectives instead of having to edit the camera directly. You can just insert the new perspective stuff. No more camera UI bundle. Apparently, you just attach the camera config component, the UI camera config component, and either your 2D or 3D camera is now a UI camera, which is, I don't know if it's an improvement, but it's definitely nice. It's another use for the multiple camera rendering things, is you could render your UI to a physical object in the world now, instead of it always having to be plastered to your screen. Most games, that's what you do, but some games you might want a UI that only appears when you walk up to pedestals or something, which just a cool thing. Custom render graphs is more or less internally Bevy split things up so that you can now specify a render graph for each individual camera instead of having to do things. And yeah, this is setting the camera render graph component. So just inside when you're inserting the bundle, you can set that, and this allows you to do things that you do with the cameras just easier. Like there's a lot of just ease improvements, and to enable and disable cameras, just set active. You know, and I guess this would allow you to like pause or unpause video cameras and things if you were doing that with the render graph. Render layers is been modified to work better with the camera-driven system. I've never used render layers, so can't really make a comment on that one. They added spotlights. That's a huge improvement for the lighting, because for the last version, we've simply had point lights and directional lights. So basically the sun, so the entire scene is lit from a particular direction, whereas spotlights now actually matter where the light is in proportion to the thing that they're lighting. Visual inheritance. This is a really nice thing for people that want to be able to toggle on large sections, like chunks of meshes or things. And it basically is that if you turn the visibility of an entity on or off, it will affect all of its children, not just itself. And their example here is this, which is not exactly the best video because it just literally shows it turning on and off, which doesn't reveal the fact that this is multiple meshes all under one parent, and with turning just the parent on and off, you can now hide and unhide the whole mesh, like all the sub meshes, instead of how it used to be, which was you needed to go through and hide and unhide every sub mesh. They show this with the example code here, but not exactly a best example because they don't show how you would have had to have done it with the old version, which would have been to go iterate through all the children and hide all those. They've added new visibility functions of is visible in hierarchy, is visible in view, and is visible. In hierarchy, I believe just means that it checks to see if any of the parents are hidden, and if so, then it returns false regardless of its visibility state. Is visible in view checks the Frustum culling before returning its verdict, and then is visible is just basically the boolean of those two combined. Is it visible at all? If both of those are true, then it is visible. And its own visibility state is true, obviously. They've got spatial bundles and visibility bundles, which is just the way of implementing all these things is they're going about for this to take effect, you need transform and visibility to both be components on all of the children, and basically the spatial bundle and the visibility bundle are just a way of adding that, because the spatial bundle automatically adds the transform and GlobalTransform and the visibility, whereas the visibility bundle, I believe, just adds visibility. And this is just, again, like a convenience way of adding this functionality. Built-in shader modules is, again, more shader stuff because that's the bulk of this update, and it's that they split their built-in shaders into smaller components so that when you are building your own shader, you don't have to re-implement this stuff, or conversely, you don't have to import huge chunks of unnecessary shader code. You can just import the specific parts of the shader that you need. And just some examples. Okay, up next is the new shader syntax. Again, just so many shader related things. It more or less just changes from square brackets to @signs. Just nice, neat, clean. I don't know. Just, again, never really done anything with shaders. Yep. So again, just a lot more of like, instead of specifying stage, just adds, boring stuff. Scene bundles. Something I've been using a lot lately with a project that I'm working on, video to come eventually, is that, instead of the way it used to work, which was you would say command spawn scene, you now insert a scene bundle, and because of the way it works is that the scene will then be inserted onto whatever entity was spawned with that bundle, because you could also insert a scene bundle to attach a scene to a previously existing component. And the main reason for doing this, which is something that I'm really appreciative for, because I have a lot of code that's literally all it was doing was acquiring a scene after it spawned and then trimming away all the shit and adding the other stuff on. Like, it would trim away the parent because it would spawn. I had to spawn it under a parent, and then it would spawn its own root node and then spawn everything under that. So it got... And I had a lot of things that were just cleaning that up. Now you can spawn in a component and then like insert directly onto that component, which speeds up the convenience a lot in terms of not having to write custom code in order to do this after the case. Parallel Frustum culling is more or less just, again, huge optimization when you're getting into the hundreds of thousands to millions of entities of it running in parallel. So I don't really know how reliable this is as a benchmark, because it will entirely depend on how many cores your computer had to how much of an impact this would have. Obviously, parallel is always going to be better than not parallel, because, well, nobody has a single core computer anymore, for one thing, so it's at least going to be a double. But more to the fact that adding the parallelization is not going to slow it down, at least not considerably. As you can see, like, these two are still really close together despite being 10 times the difference, and that's to do with the 10 times better is not worth the extra inefficiency of having to do an extra loop or whatever. But yeah, it's basically just borderline improvements. Automatic tangent generation is basically Bevy saying we've added a feature that every other game engine has, as I mentioned here. It's like they're using this particular algorithm that all the other 3D rendering programs that you're ever going to know of use. So they've now got that more online. Bevy's becoming more feature rich. Hopefully more true games get added. Now they default to linear texture filtering, which to me personally, because I love pixel art, it's a downside, but they're basically just saying, again, that Unity and Godot both default to linear texture. And if you want to use pixel art, you've got to, for each image, set it to image sampling nearest, or set the global image sampling to default to nearest. Basically, it does nothing except if, like, it makes all your images by default linear, and so, you know, got anti-aliasing, I guess. And then if you're doing pixel art, just change this to one line and you're back to the way it was. They changed the global transform matrix representation. I don't know why they've done this, but it says that it's to do with artists tend to like it, but engineers and physics programmers tend to hate it. It's more or less, it used the global transform was a vector quaternion and then a vector 3 for scale, you know, the same as the normal transform, but now it's been changed to a matrix, a 3x3 matrix, and a vector 3 for translation, which maybe optimizations are under the hood, or just a better representation of how the 3D world fits together as a global transform, but shouldn't make a difference to most people, really. ShaderType derive, again, more shader stuff. It's a derive that you can use to make Bevy automatically use a macro to implement the WGSL shader version that you can then use in your shaders. It's basic stuff again. They changed the render phase sorting optimization to be radix sort, which the big difference is it's what they call an unstable sort, which means that it will change depending, like, even if two values are the same, they may flip which is first, which I believe could result in z-fighting, but shouldn't really make that much of a difference, and is a huge speed increase, like 9 times faster. So I think for a little bit of, like, two things in exactly the same spot now might swap orders every render is much like of a trade-off. Like, it's easy trade-off for significantly faster speeds, especially considering that you could just make sure that nothing does directly overlap. Vertex Colors, you know, simple stuff again if you're into shaders, is that the standard material and color material now accept Vertex Colors as part of, like, and will use them if they're provided. Regular polygons are now available. It's basically Bevy has a regular polygons thing, and you, I guess, just specify the size and the number of sides, or like I guess the radius and number of sides, and then it will generate a regular polygon mesh for you, which again, for someone who's been working in a hexagon game, this would have been amazingly useful. Scripting is basically scripting modeling progress is that they have added untyped ECS APIs and allow you to access the ECS via pointer. That should allow for you to write hooks. For example, they're talking about this person's writing a JavaScript scripting language attachment, which basically, it just lets you access the ECS using untyped pointers with lifetimes so that Rust's guarantees still apply. That will allow you to basically pass this off to another application for scripting purposes, or to read script and run that. Query iterator, it's another thing that Bevy keeps every update. They keep making my query video more out of date, but not touching any of my others, which is hilarious. Is they basically made it so that you can just iterate over a reference, because it now implements IntoIter, and you don't have to call directly .iter on it, which is a lovely like quality of life improvement, but really doesn't make a difference. Query iter many, which is an iterator that allows you to provide a not a collection, like a collection, of entities, and will iterate over all of them, as opposed to needing to call get every time on each of them. And I don't know if it's faster. I believe, well, I was reading something that said it was faster, but I thought this feature was already in Bevy, but apparently not. And then there's the and then there's also the mutable version for this, which works slightly differently, because instead of being an iterator, because it has to enforce the not allowing multiple mutable queries at the same time, it works as a while let fetch next. So basically the same as an iterator, but you have to use slightly different syntax, because of its need to guarantee mutable aliasing. Convert mutable queries to read-only is a feature that allows you to abstract some of your code away, so you can acquire a mutable query, do some modifications, and then convert that query into a read-only version and pass that to another function. It's very quality of life stuff again. ECS lifetime pointers is, again, like I was saying about the untyped ECS thing, is they've internally changed all their things to be these pointers. So instead of using raw pointers, they now use this type erased lifetime pointer, which beyond my level of understanding with Rust, but is supposedly faster but more readable than using raw pointers, and more safe, I think. Like safety and legibility is what to say. Query internals refactor. Refactors. My brain is not working. This video is already 18 minutes long. I'm going very fast, and we're like halfway. Anyway, they refactored a lot of the internals for queries. They saying about they moved some things and made it all more accurate. They made some optimizations, so they optimized how tables move entities around, making it 16% faster. They changed how quickly entities are dropped, so that it's about twice as fast. And they changed the sparse sets index from a usize to a U32, so that it uses less space on 64-bit machines. And it slows down on 16-bit machines, but who the hell has a 16-bit machine? And then also sped up iterators by 15%, so lovely. Label optimizations, they basically made labels 30% faster internally. They've changed their labels, I think, last update, from being strings to being... Or actually, this update, what they've done is they've changed it from being a trait that you had that contained different... so all the labels were the same trait, but you could have a string or a type annotation or anything like that. They've changed it to, it now gets a system label ID, which I believe is just compiled, calculated at compile time. And so this makes it 30% faster to compare because instead of like having to compare strings and this and like it now it's just a simple compare between two IDs. This change also removed the number of requirements because I guess if it's converting it internally into like a U32 or whatever, it's going to not need copy clone. Oh, well, apparently it's not going to need partial equal and hash because they're all requirements for to compare, basically, to quickly compare types, whereas this will copy it and I guess convert it into a type, probably by hashing its implementation. I'm not entirely sure. I'd have to look into it, but hierarchy has been changed from being just like ad hoc system that occasionally goes through and checks soundness to a transaction, which basically just tweaks things. So instead of being able to query the parent and child components and directly modify where its parent and children are, you now need to use the remove child, push child, insert child commands and the with children, like, spawn bundle dot with children functions. And this just means that 100% of the time the hierarchy is correct, whereas the way they were doing it before is at a certain point in the update system, probably in the last section, it would run a system that would quickly run through and check to make sure all the changes that had been made to any of the children or parents was then propagated, which would result in them being out of sync. Now it is done in a way that you can't get the hierarchy out of sync. They've improved Bevy Reflect, which is amazing because Bevy Reflect is like a godsend for anyone who's trying to do any kind of dynamic programming in Rust, or in Bevy more specifically. But they actually mentioned down here that the system's getting to the point that they actually want it to be used in the wider Rust ecosystem as opposed to directly with Bevy, so it actually is designed to function outside of Bevy. It now implements reflecting default. It has untyped reflection. It can reflect types. You can now acquire static type information, which will be quite useful for when you're trying to make sure that something is actually what you think you're loading, when you're trying to load like code from the user. Resource reflection, which I don't quite understand, but I think it allows you to edit resources. Like in Bevy, like it'll automatically register its type and you can change it, which will, I believe, allow for scene loading to then edit resources as opposed to only being able to add components. And it also now has a nice pretty debugging thing, so instead of just telling you what type it contains, it will actually print out the information like you would expect from a debug, which is just significantly better. They talk about how they've refactored it internally, which again just talks, and then they talk more into how they want it to expand into the greater Rust ecosystem somewhere in there. Not quite sure, but yeah, it's some optimizations. Render world extract is something I've never really used, but it's to do with, I think the last version or 0.6, they split the render world and the logic world into two separate things, and you would have to make sure that you sent the information that you needed to go to the GPU to the render world, and this allowed for rendering the world and doing your logic that updated the world to be done in parallel to each other, as opposed to requiring you render the world or update the world then render the world. Is what you could do is every frame take all the information, put it in a render thing, start rendering it, and then do your updates for the next frame while you're waiting for the current frame to render, which this is just more of the they changed the API and sped up the parallelization to allow for information to be pulled from one world and put to the other, because apparently they had to do sort of ad hoc stuff to jump the gap, I guess. Extract resource traits and plugins is the same. Like, it's just extract resource is a resource that will be jumped across worlds, I believe, and they're just a bunch of now you can implement it and get it done much easier. The UI has been migrated to Taffy, so it says here that they used to use Stretch, but that's no longer maintained. So they've swapped to the community fork that has become Taffy, and the Bevy team is now actively maintaining the Taffy fork. along with the Doxus team, and they've cleaned up the code base, made it a lot better, and improving. And hopefully Bevy's UI will now take leaps and bounds forward, because I had no idea that the crate that they were building their UI on top of was not maintained. So some soundness and correctness is basically they've removed a bunch of API stuff that was causing memory leaks and was unsafe and stuff like that. Again, not really important unless you're actively digging into that, so read it if you're interested. Android made some progress in terms of that you can now render on it, but it causes issues. I think they said it's something about if can break, sometimes break on startup and always break when minimizing the tab. So it's not there yet, but you can start testing and writing code. If, in the future version, in a couple months, it'll hopefully be there. Some CI stuff, which again, not really important unless you're actively working on adding to Bevy, is it does things like runs tests and takes screenshots of them, runs once a day on a virtual machine. So basically, Bevy should never be code breaking and much more stable to work on on the nightly builds or the main branch of Bevy instead of the official release. If you want to be more up to date and have more features, they added some new examples. So a post-processing example, a many animated foxes example. This is an example after my heart, and it's just a skeleton animation system, just lots of foxes walking in a circle, some WASM build tools, website improvement stuff. Again, there's a lot of stuff that's not really important. And then they've changed how the Bevy organization works. So more or less they I'm not quite sure if they promoted them or just changed the title of these two main mergers, and then they've added another one of the maintainers. And then they've done a rework of how things get committed. So hopefully this should mean that Bevy has more large updates every few months, as opposed to while it was for a while where it basically went like 6 months and then you got like a big update, like in terms of like must have a lot of work gone into it, but it didn't like add nearly as much as it could have. So now it's a lot of like there's no hard limit to where a maintainer is allowed to try and put pull requests. For a while they had like document only and rendering only sort of people, where it's like you were only allowed to work on the rendering codes, and now it's like you can work anywhere as long as you feel comfortable working there. And obviously it's still got some oversight, so you can't, nobody can just go in there and mess with anything. And the maintainers can merge relatively uncontroversial PRs with to community approval, and then completely trivial PR, as it's called here, without the two, which is basically saying like if you're adding something that's not particularly bad, like just some small feature or something, you can do that as long as like 2 community approvals. And then if it's something like typos or renaming something like an API consistency fix, then you can do that without even getting without the 2 community approvals. And then there's also there's a controversial decision making on a timer. Is basically once a decision gets to a certain point, it gets marked in a certain way, and then the main maintainer of Bevy, Cart, gets pinged, and he's basically got 45 days to respond with a feedback to fix it, give him more time, or no, it's not going in yet, like we aren't ready yet, or a veto in that time. Otherwise, they're perfectly free to add it in themselves. But then also, Cart reserves the right to veto anything he doesn't like, completely change anything he wants, and undo any of those controversial changes coming from 4. But this should just mean that basically the Bevy keeps moving forward quickly, even if Cart himself isn't directly marking off everything. And then finally, we're getting to the end. Oh my God, is post-processing is up next. Like in the next update, we're going to have post-processing, asset pre-processing, scene system improvements, which I'm hoping and looking forward to, Bevy UI improvements, which is great. And here's a big thing I'm looking forward to for my channel is Bevy Jam 2, because I probably won't be participating. Yep. Because I'm terrible at actually making games. I'm more of a documentation and consolidation person. But I will hopefully find the time to play and put some of these games on my channel and show off Bevy in a cool practical sense. But I hope you've enjoyed the video. Like, comment, subscribe, and stay tuned for the migration guide that I will be releasing maybe later today or tomorrow, sometime this week for sure. And I will have a link in the description to this document if you want to read into anything and get more further clarification. I hope you've enjoyed. Like, comment, subscribe.